Now let's look at adding an objective function. So my objective, say, is that I want to maximize, and I'm just going to pick something arbitrary here. Suppose I want to maximize the sum of 2x plus y. Now notice I get a warning triangle because Desmos just doesn't know what to do with 2x plus y. If I just have 2x, it thinks what I mean as y equals 2x. And so there it plotted y equals 2x. But as soon as I say plus y, it's not sure what to do, because normally it would have like y equals 2x, but there I have a y. So it's confused. And what we need is our equation, and I want to maximize 2x plus y. Now, I don't know what I can maximize it to. I have no idea if I can make that sum, for this feasible region. So I have this feasible region, and now notice, if I click here at some point, and well, I guess it's not showing me what the point is, but there's 2, there's 3. So suppose I have x equals 2 and y equals 3, then, well, 2 times 2 plus 3 is equal to 7. So I see that, I can at least make that sum 2x plus y at least 7. And so what I'm going to do is actually try something a little bit more systematic than picking points all over the place. I'm just going to try a value. So there's 2x plus y equals 5. Now I'm going to do it again. 2x plus y equals 10. Okay, so there's another line. Now, so this black line, all values on there, if I take 2x plus y, I will get 5. That's exactly what that equation says. Whatever x is, whatever y is, if I take 2 times the x plus the y, I get 5. And that's why that line is there. And so similarly, I'll try upping it to 10. And notice I still have a bunch of things in the feasible region. So everything from the 1, 8 right there to the 5, 0, those are all in the feasible region. So any of those could make 10. So for instance, I could use x equals 3 and y equals 4 and get 10. But notice what's happening. When I had 5, I was here. When I made 10, it moved to the right. Now what happens if I do 15? 2x plus y equals 15. Now there it moved to the right about the same amount there. Well, actually exactly the same amount. But now notice, here is the edge, well, up here, so there's the 8. Here is the edge of my feasible region. Now in the project, for the feasible region we have in there, I actually highlight it with a black border just so we can see it easier. You have to look a little harder here, but when we look at the darkest part of the orange, I see that it starts, it's always the positive part, so they're the x and y axis. And then we go up here, go up there, go over to here, and then there. And so this is nowhere inside there. But there are other points in between the line for 10 and the line for 15. And well, so I can either, since this point looks really close to the 15, I'm going to back off. I'm going to start with the 15 and go 2x plus y equals 14. And well, that's really close, but it's not quite there. There is a point right there. And now, 2x plus y equals 13. And actually that's inside, so see there from the 5, 3 up here, the 4, 5, in between x equals 4 and x equals 5, I've got I've got various things that are inside my feasible region. Now, and I didn't pick these out to begin with, so they aren't nice numbers in the sense of whole numbers, but I should be able to pick something between 13 and 14 and hit right up here at that spot, the 5 and the 3.75. And so I'm just going to mess with this 13. I'm going to try 13.5, and you see that's not quite there yet. So I'm going to try 7.5, and I think it's there. You see there's one little gray dot, and there is the 5 and the 3.75. And that is as big as I can make it, because you see if I move any more to the right, I'm going to be outside the feasible region. If I move any to the left, well, I'm inside the feasible region, but if I move to the left, that is making my 13.75 smaller. So, if I go down to 13, it moved that black line to here. Well, 13 is not as big as 13.75. So that's as big as I can make it. And so there, I have found my maximum value for 2x plus y, if that's what I want to maximize. Now, I didn't give it a story. I don't know why I would want to maximize 2x plus y. Now, in our project, we maximize x plus y. And that makes sense for us because x is the number of people being evaluated at one center, and y is the number at another center, and we would like to make that total number as big as possible. So we would like to make x plus y as big as possible. But just to show, well, I can use 2x plus y. I can use all sorts of different things. I could do 2x minus y for that matter, and look at that. But it turns out my maximum value is 13.75, and then what I see is that occurs when my x is 5 and my y is 3.75. So again, I don't know if 3.75 for y makes sense. In our project, no, 3.75 wouldn't make sense because you don't have 3 3/4 individuals. And so for us, that wouldn't be a practical answer, and we would want to back this thing up a little bit to the 13, where we'd get a whole number answer. So with 13, well, we could either do the 4, 5. I don't know if any of those are, if we have nice integers anywhere else, I could kind of have this go along here. 4, well, I guess this is 5, so we wouldn't. So either 4, 5 or 5, 3 can make the 13. But I never said anywhere that in this case that x and y had to be whole numbers, and so I'm going to go with the biggest I can make it, which is 13.75, and with x equals 5 and y equals 3.75. So that's how I would go about graphically determining my maximum value for any given objective. Okay, and so real quick, let's just make it 2x minus y, and suppose I want to maximize that. So I'm just going to look at all these different things. Now I'm going to have to figure, I'm not really looking at what I have here. I'm just going to get rid of those two just to see what's happening. So the black line is 5, the blue line is 10, the green line is 15. Well, once again, here's where we start. The blue line looks like that might be as good as I can do, because here's my feasible region. There's a corner right there at 5, 0. And so 10 appears to be the best I can do. Is I can make 2x minus y as big as 10, and I can do it when it hits 5, 0. Again, well, I could go with this line, the 5, but 10 is bigger than 5. So why would I go with 5? I go with 10. I could try this line, but we're out here and nothing here is in this feasible area, so I can't do it. So now notice what happens is actually, because of the fact we're using straight lines, is your answer, wherever it is always going to be at one of these corners. So we've got all these different corners here. I think it makes, I don't know how to, oh yeah, so there I kept a bunch of them. So there are corners. There's a corner here, and I lost all the others. There's a corner there, and there's even a corner here at 0, 0, which under certain circumstances could be the best answer. So you see, it's going to be actually always at one of these corners. Now, I could do something, you can even get some weird kind of things where if I pick just the right thing, suppose I want to maximize 5x plus 4y equals, now actually because I picked a constraint up here, I know that it's going to be 40. And so it can happen that actually whatever you're trying to maximize or minimize, whatever you're trying to work with as your objective, could actually turn out to match one of your constraints. Now you may not know it, because for instance, I could have had this be a 10, an 8, and an 80, where what I did was I just multiplied everything up here by 2. So it doesn't quite look the same as my constraint up here, but it turns out it really is. It's the same line. And so your objective could actually be the same as one of your constraints. Doesn't usually happen, but it can. And in that case, we're still at corners. That corner and that corner both work. So it's still true that it works at the corners, but it also works anywhere. I'm going to turn these others off. It also works anywhere in between those two corners, in this case, because, well, all those lines fit those constraints. So, or all those points, sorry, fit those constraints. So anything in between here would actually work as well. So it's not, there's not always just a single answer. Sometimes you can have a whole lot of answers, anything in between the 2 points, but it's not typical. Usually you're going to have something like we had with whoops, wrong one, that one, where it only hits at a single corner. Okay, so that's the idea of putting an objective in then with our feasible region. And once we know how to work with an objective for a feasible region, we can, at least as long as we have just these 2 variables, we can find the best solution for anything we want to work with.